Have you ever gazed up at the sky on a clear, sunny day? It's a sight we often take for granted, this vast expanse of blue above us. Yet, have you ever stopped to wonder why the sky is blue? Why not green, purple, or even yellow? The answer lies in a fascinating phenomenon known as Rayleigh scattering. It's a tale of light, air, and the magic of our atmosphere. We perceive the sky as blue because of how sunlight interacts with Earth's atmosphere. To understand this, we need to first understand light itself. Imagine sunlight as a wave, traveling millions of miles from the sun to Earth. During its journey through the vacuum of space, sunlight remains largely undisturbed. It's only when sunlight reaches Earth's atmosphere that things start to get interesting. Our atmosphere acts like a giant prism, bending and scattering the sunlight in all directions. The Earth's atmosphere is composed primarily of nitrogen and oxygen molecules. These molecules are much smaller than the wavelengths of visible light. Now imagine these air molecules as tiny bells. When sunlight, carrying all its colors, strikes these bells, it causes them to ring. The smaller bells, representing nitrogen and oxygen, ring at a higher pitch when struck by the shorter wavelengths of blue and violet light. This ringing is analogous to the scattering of light. The scattered blue and violet light then reach our eyes from all directions, making the sky appear blue. Rayleigh scattering is named after Lord Rayleigh, a British physicist who first described this phenomenon in the late 19th century. He discovered that the intensity of scattered light is inversely proportional to the fourth power of the wavelength. This means that shorter wavelengths are scattered much more strongly than longer wavelengths. To put it simply, blue light is scattered about 10 times more effectively than red light by our atmosphere. This is why we see a blue sky most of the time. If you were to look at the sky from the moon, which has no atmosphere, the sky would appear black even during the daytime. However, the sky doesn't appear violet, even though violet light has an even shorter wavelength than blue light. This is due to a combination of factors. Our eyes are more sensitive to blue light than violet light. Additionally, the sun emits slightly less violet light compared to blue light. But what about sunrises and sunsets, you might ask? Why do they appear red, orange, and pink? The answer again lies in Rayleigh scattering. During sunrise and sunset, sunlight has to travel through a larger portion of the Earth's atmosphere to reach our eyes. As sunlight traverses this longer path, most of the blue and green light is scattered away, leaving behind the longer wavelengths of orange and red, which are scattered less efficiently. This is why the sky near the horizon appears reddish during these times. The specific colors of a sunrise or sunset can also be influenced by other factors, such as the presence of clouds, dust, and aerosols in the atmosphere. These particles can further scatter and absorb sunlight, creating a breathtaking palette of colors that paint the sky. The Earth's atmosphere is a dynamic and ever-changing canvas. It's not just about the blue sky or the reddish hues of sunrise and sunset. The atmosphere is a complex mixture of gases, water vapor, and tiny particles like dust, pollen, and pollutants. These atmospheric components play a crucial role in scattering and absorbing sunlight, contributing to the wide range of colors we observe in the sky. For instance, clouds appear white because water droplets within them are much larger than the wavelengths of visible light. These droplets scatter all colors of light equally, resulting in the perception of white. Pollution, on the other hand, can have a significant impact on the color of the sky. Pollutants in the air can scatter light differently and even absorb certain wavelengths, leading to hazy skies and muted colors. Understanding why the sky is blue is just the beginning of a fascinating journey into the world of atmospheric optics. From rainbows and halos to auroras and light pillars, our atmosphere offers a breathtaking array of optical phenomena, each with its unique story to tell. So the next time you look up at the sky, take a moment to appreciate the intricate dance of light and air that paints our world in 1,000 shades of blue. It's a reminder that even the most commonplace occurrences in nature can hold profound wonders waiting to be explored. This is just a glimpse into the vast and fascinating field of atmospheric science. There is so much more to discover and learn.